Hello everyone, thank you for taking the time to view this video. So for this afternoon, we are going to study two topics. The first one being multiplying polynomials, and the second one being dividing polynomials. So let us have the following. We already know the concept of multiplying even before back in elementary. Is like just simply asking what is 9 times 3 being 27, what is 8 times 4 being 32, and so on and so forth. But this time, instead of us just multiplying numbers, we are now multiplying together variables. And we need to be reminded of some of the key concepts that we need to use when we do multiply polynomials. So that includes the laws of exponents. The laws of exponents needs to do with the following. Let's say you have encountered a product law. Product law just says if you need to multiply something of the same basis, let's say both of them are x but with different exponents, like say both of them having an exponent of m and n respectively, we just simply do this by keeping the base, which is x, and adding their exponents, which is m plus n. And the second one is the power law. Let's say I have x raised to m is raised again by another exponent outside, which is n. What we need to do is keep their base and multiply the exponents. So with that out of the way, let's discuss this furthermore. Let's have example number 1. Example number 1 is about multiplying polynomials. When we have this, so let's try to answer number 1. So we already have the solutions, but let's try to answer this carefully. So we have a given 6y cubed times 3y to the fifth. The first step when we multiply monomials is that let's analyze their numerical coefficients. On this case, those numerical coefficients are 6 and 3. So let's multiply them first. And next, we have their variables, which is y. And we can also multiply that separately. Thus having this, which is the following. We have y to the third times y to the fifth. If we do that, if we solve for this separately, 6 times 3 being 18, and y to the third times y to the fifth follows product law by adding 3 and 5. If we simplify that, the answer will be now 18y to the 8, thus confirming our answer here on this example, like this one. There you go. So far so good, right? It's so simple. That also applies for the next example. Let's have it as 3mn squared times the quantity of 9m squared n. Now let's do the following. For this one, we first analyze their numerical coefficients being 3 and 9. So let's first multiply 3 times 9. Then we can also multiply those with the same basis. For this one, it's m times m squared times n squared times n. Now let's simplify. Thus 3 times 9 is 27, and m times m squared is m cubed because we add their exponents, and n squared times n is n cubed because we add their exponents 2 and 1. So far so good. I will leave this example or some examples for you to answer and verify if the answer is indeed true. With that out of the way, as a reminder again, we use this property. or known to be the product law. Product law of exponent. So yeah. Next would be when we take note, when we multiply now a polynomial by a monomial, we use the distributive property. Distributive property just looks like this. If we multiply a to the quantity of b plus c, we will arrive at distributing a or multiplying a to both b and c. Thus, looking like this: ab or a times b plus ac or a times c. Next, if we do confirm this, let's say I write this as 4 times the quantity 3x squared plus 4x minus 8. Let's try to solve this using distributive property. Distribute 4 to the numerical coefficients 3, 4, and negative 8 respectively. Thus, if we do that, we will arrive at 4 times 3x squared plus 4 times 4x minus 4 times 8. Or to be specific, plus 4 times negative 8. Either way, you will still arrive at the same answer. Let's confirm. Here, 4 times 3 is 12, and we are left with x squared. 4 times 4 is 16, and we are left with x. And last but certainly not the least, 4 times negative 8 is negative 32. Thus confirming our answer is correct. So far so good, right? This one, let's have this example. We have 6pq times the quantity of 2p minus q. If we solve for this one, we need to distribute 6pq to both 2p and negative q. If we do so, that will be 6pq times 2p plus 6pq times negative q. Answering the following, we will solve like having 6 times 2 first, which is 12. P has something similar, which is p times p. And if we solve for that, that answer is p squared, because these have both an exponent of 1. And q, however, has nothing similar, so we just write q. And we multiply 6 to negative 1. The answer for that by 6 times negative 1 is negative 6. We have nothing similar to p here, so we just copy p. But however, q is similar with q. So q times q is q squared. Thus, the final answer does confirm that it's 12p squared q minus 6pq squared. And with that, let's confirm. If you want to answer this on your own, I will leave this to your discretion. Continuing, let's answer or verify if the following is true. So I'm gonna answer all of the odd numbers, which is 1, 3, and 5. I will leave the other exercises for you to answer 2, 4, and 6, so you can pause the video and check if your answer is correct. So let's answer number 1. Number 1 goes along like it's 3m times the quantity m minus 8. Again, be reminded, we distribute whatever is outside to both the terms inside of it. Thus, we will have 3m times m plus 3m times negative 8. Since we have no numerical coefficients here, or the numerical coefficient is 1, 3 times 1 is still 3. N times m is m squared. Then, the numerical coefficient 3 times negative 8 is minus 24 or negative 24. And we are left with m. So the final answer is 3m squared minus 24m. For number 3, we can see that we distributed negative 2x squared to the quantity 3x squared minus 6x plus 7. Doing so, we will arrive something like this. We distribute negative 2x squared to both 3x squared, and we distribute again to negative 2x squared to negative 6x, and we distribute negative 2x squared to positive 7. Simplifying the following, negative 2 times positive 3 is negative 6. X squared times x squared is x to the 4th because we add 2 plus 2. Negative 2 times negative 6 is positive 12. X squared times x is x cubed by means of adding their exponents. Negative 2 times 7 is negative 14, and x squared times nothing, or rather nothing similar to it, so we just keep x squared. Thus confirming that the answer to number 3 is negative 6x to the 4th plus 12x cubed minus 14x squared. The last value that we need to solve so that you can solve for the other ones is that we have for number 5 negative b to the 7 times the quantity b squared minus 2b plus 3. If we do so, by distribution, we will have negative b to the 7 times b squared minus b to the 7 because it's negative b to the 7 times negative 2b minus b to the 7 times 3. Solving this furthermore, negative 1 times positive 1, or because negative times positive is negative, then b to the 7 times b to the 2nd power, we just add. So it's gonna be b to the 9th. Negative times negative 2 will become positive 2. And b to the 7 times b is now b to the 8th. Negative times positive 3 is negative 3. And we are left with b to the 7. Thus the answer is negative b to the 9 plus 2b to the 8 minus 3b to the 7th power. You can pause the video if you want to solve or verify for numbers 2, 4, and 6. For this method of multiplying a binomial by a binomial, I will skip this one, the distributive property, because there's much simpler terms on how we can do that. This is what you call the FOIL method. So both of them have the same given. So we should arrive at x squared plus 5x plus 6. But we can solve this faster using FOIL method. FOIL method stands for F for first, O for outer, I for inner, and L for last. Doing so, if we have the given x plus 3 times the quantity x plus 2. Doing FOIL method again, we do first, the first terms being this one. Conveniently, the answer for x times x is x squared. Second, we do the outer. Outer being the outer terms within the 4. So that is x times 2. The answer is 2x. The inner terms, which is 3 times x, will become 3x. And last but certainly not the least, the last terms being 3 times 2, the answer will become 6. Now let's write every single term that we see in descending order according to their degree. So we can see that the first one, which is the highest, is x squared. Then we see positive 3x, then positive 2x, and positive 6. So with that out of the way, Let us check whether this is already simplified. As we can see, we can still simplify adding 3x and 2x because they are similar terms. And if we do so, this will become 5x. Thus, the final answer is x squared plus 5x plus 6. There you go. So far, so good, I think. Yep. Again, if you want to verify this, you can solve this for yourself, then check. For the next ones, that also is the same. Okay, this last one should be discussed properly. Okay, now, to multiply polynomials with more than 2 terms, you can use the distributive property several times. Let's say I have 5x plus 3 times the quantity 2x squared plus 10x minus 6. First things first, you can observe that we can distribute these two separately. So I'll start first with 5x. So I will distribute 5x first to this entirety. If I do so, we will have 5x times the quantity of 2x squared plus 10x minus 6. But we are not done yet. We also need to distribute the one that we left, which is positive 3. So that will be plus 3 times the quantity of the same thing, which is 2x squared plus 10x minus 6. Solving this one by one, 5x times 2x squared, or 5 times 2, is gonna be 10. X times x squared is gonna be x cubed. 5 times 10 will be 50. X times x is gonna be x squared. And last but certainly not the least, 5 times negative 6 is negative 30. And x times nothing, or rather no variable, is just x. And last but certainly not the least, we distribute this 3. So 3 times 2 is gonna be 6, and we are left with x squared. 3 times 10 is gonna be 30, and we are left with x. And last, 3 times negative 6 is negative 18. But before that, we add the similar terms. Similar terms being these two x squareds can be added up together. And if we do so, we will have 50 plus 6 is going to be 56x squared. A positive and a negative of the same time, or rather a negative and a positive, if you add them, it will just cancel out. So there are no more with the x. Thus, we can already rewrite this simplified version, which is, bring down this, which is 10x cubed plus 56x squared minus 18. And we are done. There you go. A more convenient way on how we can do this is that we can use the rectangle model. By means we have a given already earlier, like 5x plus 3 times the quantity 2x squared plus 10x minus 6. Doing so, we can use the following, wherein you can multiply, or rather write 2x squared plus 10x minus 6 horizontally. So that will be 2x squared positive 10x negative 6. And we can write 5x plus 3 vertically, or we technically you can just actually interchange them. Either way, you will still arrive at the same answer. Doing so, when I separate all of these into grids or using the rectangular method, it will look around something like this. It will look something like this. There you go. So, let's now do their cross multiplications. Conveniently, this and this multiply to each other. Thus, the answer will be 5 times 2 is 10, x times x squared is x cubed. 2 times 3 is 6, and x squared times no variable is x squared. 10 times 5 is 50, x times x is x squared. Then 3 times 10 is 30, and x, just keep that. And for this one, 5x times negative 6 is negative 30x, and 3 times negative 6 is negative 18. Now, with that out of the way, let's add similar terms. Let's start with x cubed. So, there's nothing similar to x cubed, so I'm just going to write 10x cubed here. X squared, meaning 6x plus 50x, is going to be positive 56x squared. A positive 30x and a negative 30x just cancel out each other. And last but certainly not the least, we write negative 18. Thus, we also still arrive at the same answer as earlier. So far, so good. So, yeah, if you wanna check out that you can furthermore review this part, you can pause the video if you want, so that you can identify what you need to learn. Okay, we can now move on to this one. I think you can also use this vertical method if you want, but either way, you can still identify using this rectangular model. I think the rectangular model is much easier than this one. You can do this individually. You can pause each part. You can rewind just in case. And with that out of the way, if you have any questions, just let me know. If there are any clarifications you want to ask me, you can message me on Gmail chat. And now we move on to dividing polynomials. It's essential for us to know how we multiply first, before we divide. So let us be reminded, in a law of exponent, this is essential. This is the quotient law. When we divide a certain number with an exponent m over the same base but with a different exponent, we do this as we subtract the exponent of the numerator and the exponent of the denominator. There will be three cases. If the subtraction between m minus n is, let's say, greater than 0, or it's positive, let's say 7 minus 3, the answer is 4, so it's greater than 0, right? The implication is just we write that normally as whatever will be the answer. Case number 2, if m minus n is less than 0, it means, let's say, we reverse that. 4 minus 7 is equal to negative 3. And negative 3 is less than 0, right? Thus, we do this by already writing 1 over a n minus m, so that we can already write that in the denominator. Because there's this another law, which is negative exponent law. If we see a raised to negative m, we tend to write that as 1 over a raised to the positive m. Last but certainly not the least, if m minus n is equal to 0, or in some cases 7 minus 7 is equal to 0, if you write an exponent 0 is just 1, because any number raised to 0 is equal to 1. Now, using those information, we divide now first monomials to monomials. If so, let's check this one. Number 1, we divide 20 x cubed over 4x squared. First things first, we divide using the following. We divide using the following. So thus, the first one goes along that it will be 20 divided by 4. That's the first thing that we need to analyze. Let's divide their numerical coefficients. And next step will be, we need to multiply it by using quotient law, which is rewrite the same base x, then subtract their exponent 3 minus 2. On this case, 20 divided by 4 is 5, and x raised to 3 minus 2 is equal to 1. But in this case, I don't need to write the exponent 1. Thus, the final answer is 5x. So far, so good, right? Now, let us have the next example. Example number 2. Example number 2 goes along like this. Let's zoom on this one. So, number 2, if we have a lot of arrays of numbers and variables like this, let's do them one by one. First, for 36, a to the 4th, b to the 12th power, c, d to the 5th power, all over 9, a to the 3rd power, b to the 7th, c, d to the 5th power. First things first, its numerical coefficient, which is 36 divided by 9. The answer is 4. Next, we do quotient rule for each one of them. A to the 4 minus 3. So a to the 4 minus 3 is gonna be a to the 1 power, but we do not write the exponent 1. B to the 12 divided by b to the 7, which amounts to b to the 12 minus 7, is 5. C just cancels out because c divided by c is 1, and we do not write 1 again. Same goes for d to the 5th over d to the 5th. The answer is 1. So the final answer for this one is 4ab to the 5th power. I guess some of the practice is already self-explanatory for this one, so that if you want to verify your answer, you can look. And with that, let's move on to how now we divide a polynomial by a monomial. Earlier, we just divided monomial to monomial. But this case, we need to divide a polynomial by a polynomial. First, let's write the given 3x squared plus 15x minus 24 divided by 3. What we do here is we divide 3 to each of the terms here, being we divide 3 to 3x squared, which looks like 3x squared over 3, and we continue with the rest, 15x over 3, and minus 24 over 3. Simplifying everything, 3 divided by 3 is 1, but we are left with x squared. 15 divided by 3 is 5, and we are left with x. And 24 divided by 3 is negative 8, to be precise, because we have this negative symbol. Thus the final answer is x squared plus 5x minus 8. Next, we divide the polynomial by a monomial, like this one as well. On this case, we have 32x squared plus 18x minus 20y divided by 8. Again, we divide that 8 to each one of them. So it would look something like 32x squared over 8 plus 18x over 8 minus 20y over 8. In this case, 32 and 8 divides evenly. So the answer is 4. And we are left with x squared. The next one, 18 divided by 8 does not divide evenly, but we can simplify them by dividing them by their GCF. And their GCF is 2. I can divide 2 to them. So it will something look like 18 divided by 2 will be 9. And 8 divided by 2 will be 4. And take note, we are left with x minus 20 and 8 can be divided both by 4. And if we do so, 20 divided by 4 is 5. And 8 divided by 4 is 2. And we copy their exponent y. Thus the final answer is 4x squared plus 9 over 4x minus 5 over 2y. You can verify this next example by doing it on your own. Pause the video if you want to solve it for your own so that you can move on to the next one. Okay, now let's move on to this one. You can also do that individually. Pause the video if you want to have an exercise so that you won't be confused. But to elaborate this, be careful of the ones that will be left. On this case, r squared divided by r is r, s squared divided by s is s. We can cancel out both 3r on this one, but we are left with s squared divided by s. That's why we have s. And 9 divided by 3 is 3. R squared divided by r is r. And s divided by s is equal to 1. So, indeed, to confirm, the final answer would look something like this. You can do the individual practices on your own if you want to try it for yourself. Again, for this one, I will answer now the odd numbers. So, I start off with number 1. Number 1 has 9x squared minus 3x plus 12 divided by 3x. Next, what I do with this, again, I divide them all by 3x. Thus applying 9x squared over 3x minus 3x over 3x plus 12 over 3x. If we check this, we will arrive at 9 divided by 3, which is 3, and x squared divided by x is x. Minus, we divided evenly because 3x divided by 3x is equal to 1. So, but here's the thing, we have negative, thus it's negative 1. And we plus 12 divided by 3, the answer is 4, but we are left on the denominator, x. Thus, the final answer is indeed 3x minus 1 plus 4 over x. Third example. We have 8x cubed minus x squared plus 2x minus 1 all over 2x. If we do so, 8x cubed over 2x minus x squared over 2x plus 2x over 2x minus 1 over 2x. We divide 2x to all of the terms on the numerator. Thus, 8 divided by 2 will be 4. X cubed divided by x will be x squared because 3 minus 1 is 2. And minus x squared divided by x is gonna be x. But here's the thing, we will be left with 2 in the denominator. Plus, the same thing being divided will just be equal to 1. And last but certainly not the least, we don't do anything with this one because it's already in the simplest form. Thus, we just write 1 over 2x. Thus confirming that this is the final answer. Pause the video if you want to solve for numbers 2 and 4. So we are done with the first objective. Now let's do the second one. How do we divide two polynomials similar to dividing two numbers? Let's skip this one because we already have this part already in the lesson. And let's focus on this one. Let's have the first one. It looks something like 2x squared plus 10x plus 1. And we divide it by x plus 3. If you want to do this first using long division, first we write its dividend, which is in the top, as if we are completing everything. So just to see if indeed each one is complete, it should be like from decreasing degree. So we started off with x squared. So x squared going to x, then going to the constant. Let's see if it has the complete one. So this is x squared, this is x, and this is the constant. So indeed this is already complete. The next one, we put its divisor on the left side, which is x plus 3. Now, the next steps that we need to do is that we need to check for the first terms on both the dividend and the divisor. Those being here, which is 2x, and this being here, which is x. So if we check that, this is x, 2x squared, and this is x. Let's just divide them individually. What is 2x squared divided by x? The answer will become let me move this here. There you go. So 2x squared divided by x will be something like 2, cancel 1, will be x. We write this 2x above 2x squared. So it's gonna be like this. It can either be above here or above here, but I tend to write it here. So 2x. What we do with this 2x is we multiply that to both x and 3. And if we do that, 2x times x is gonna be 2x squared. And 2x times 3 is gonna be 6x. And we put it down to where it has the same or similar terms. And what we do here is subtract. Again, let us be reminded, when we subtract polynomials, we change the sign and perform addition. So I'm gonna change this to addition, but we change the sign from positive 2x squared to negative 2x squared. And from positive 6x, we're gonna have negative 6x. If we do so, this will be eliminated or 0 already, but 10x plus negative 6x is gonna be 4x. And then we bring down 1. Again, we just do the same step. We look at the first term. On this case, it's gonna be 4x now. But on the divisor, we have x. So 4x divided by x is 4. So we write this positive 4 here. If we do so, we need to multiply that 4 again to both x plus 3. Doing so, we will have 4 times x, we're gonna be 4x. And 4 times 3 is gonna be 12, or positive 12. Again, when we subtract, we change their signs and change the addition. So I'm gonna put addition here, but take note, we need to change the signs. From positive 4x, this is gonna be negative 4x. From positive 12, this is gonna be negative 12. This will be cancelled out because positive 4x plus negative 4x is gonna be 0. And negative 12 plus 1 is gonna be negative 11. Thus, negative 11 is our remainder. How we write for the final answer is like this. Dividend over divisor is equal to the quotient plus the remainder over the divisor. We have the quotient, which is 2x plus 4. So I'm going to write 2x plus 4 plus the remainder, which is negative 11. But we are not done with just writing negative 11. We need to write divided by its divisor of x plus 3. Thus solving our problem here. Okay, you can pause the video, and if you want to rewind, you can again check whether you want to verify your solution. On this one, for number 2, again, there's some importance for me why I highlighted checking if each terms is complete from its descending form. So in this case, x cubed plus 3x minus 4 all over x plus 2. If we observe, we have x cubed, but we don't have x squared. But follow that, we have x, and we have the constant. X cubed corresponds to, of course, x cubed. X squared corresponds to 0 because we don't have something. X corresponds to 3x, and the constant being negative 4. If you want to represent this properly, we can write it like x cubed plus 0x squared plus 3x minus 4. There will be a purpose why I write 0x squared. You will see that when I did this division. Okay, now let's do the following. Again, we write the dividend inside and the divisor outside, which is x plus 2. And now let's divide them separately. So we see the first terms being x cubed on the dividend, and the divisor being x. X cubed divided by x is x squared. This x squared, we need to write it above x cubed. And just multiply x squared to both x and positive 2. Thus x squared times x is x cubed. X squared times 2 is gonna be positive 2x squared. And then we perform again subtraction by changing this to addition and changing every sign to its opposite. This will become negative. This will become negative. If we do so, this will be cancelled out. But 0 plus negative 2 is negative 2x squared. And now that is the purpose why we have x squared or 0x squared there, so that we have a placeholder. And then we bring down positive 3x. Now let's continue. We see the first terms as negative 2x squared. We divide that by the first term of the divisor, which is x. And if we do so, the answer is going to be negative 2x. We write minus 2x here so that we multiply negative 2x to both x and positive 2. Doing so, negative 2x times x is negative 2x squared, and negative 2x times positive 2 is going to be negative 4x. Rule of subtraction, change the addition, then change the sign. This will be now positive. This will now be positive. Negative 2x squared plus positive 2x squared is just cancelled out. 3x plus 4x is gonna be 7x. And last but certainly not the least, let's bring down this 4 or negative 4. So we see, observe that 7x, the first term now, divided by the first term in the divisor, which is x, the answer will be positive 7. Thus, we multiply the 7 to both x and 2, thus arriving at 7x plus 7 times 2 is 14. And then again, rule of thumb. Did I delete that? Wait, did I do something? Oh, yeah, there. Rule of thumb is that again, we change the sign to, or rather, we changed it from subtraction to addition and then change the signs. This will become negative. This will now become negative. Cancel this out. Negative 14 plus 4, or negative 14 plus negative 4 is gonna be negative 18. Thus, the final answer can be rewritten something like x squared minus 2x plus 7 plus the remainder negative 18 divided by the divisor x plus 2. Thus answering this question. And so far so good. Now let's check for the other examples. For this one, now we are dealing with 3 terms. Thus we need to divide them accordingly like this. First, let's verify if the terms are complete when before dividing. So looking at this, we will have 6x to the fourth, then x cubed. So far so good, complete. 6x squared, complete. We have for x, which is negative 5x, and the constant is negative 3, so the dividend is complete. For the divisor, we have 2x squared plus x minus 2, which is also complete. Now we do this. Again, first step, we write the dividend inside, which is 6x to the fourth minus x cubed minus 6x squared minus 5x minus 3. And we get the divisor and write it to the right side, which is 2x squared plus x minus 2. First step, first terms, which is 6x to the fourth divided by 2x squared. 6 divided by 2 is 3. X squared divided by x to the fourth divided by x squared is going to be x squared. So we write 3x squared here. Doing so, we will have multiply 3x squared to the entirety of the divisor, which will be 6x to the fourth plus 3x cubed minus 6x squared. If you want to add this, we need to change every signs. This will become negative, this will become negative, this will become positive. Negative and positive will become 0. Negative x cubed plus negative 3x squared is negative 4x cubed. But positive and negative of something will be 0x squared. Then we bring down negative 5x. We see the first terms being negative 4x cubed. We divide that by the first term in the divisor, which is 2x squared. Negative 4 divided by positive 2 is negative 2. X cubed divided by x squared is x. So that is minus 2x. You multiply this minus 2x to all of them. So this will become negative 4x cubed minus 2x squared plus 4x. Rule of thumb, add, change the signs. Positive, positive, and this will become negative. Thus, canceling out this one, we will have 2x squared. You will have 9x or negative 9x. We see 2x squared divided by 2x squared. The answer is 1. We write that 1 and multiply it to all of them. That will become 2x squared plus x minus 2. If we want to add, change their signs. This will become negative, this will become negative, this will become positive. Cancel this out, you will be left with negative 10x. If we add these, this will become minus 1. Thus the remainder is negative 10x minus 1. The quotient being 3x squared minus 2x plus 1. And then we add the remainder, which is negative 10x minus 1 all over the divisor, which is 2x squared plus x minus 2. Thus completing our solution. So far, so good. Now, you can do this practice on your own. If you want to verify the answer, you can ask me in Gmail chat. Okay. Next. There's another method for finding the quotient of polynomials, or to be specific, a polynomial to a binomial. So, it can be used if the divisor is in the form x minus c, where c is any real number. So here are the steps. Let's say you have here earlier, which is 2y squared plus 3y minus 11. When we divide that by y minus 3. The first step is that we need to assure that we need to write every numerical coefficient from descending order to see if they're complete. So y squared corresponds to 2, y corresponds to 3, and the constant corresponds to negative 11. So far, so good. So now, the second step is that we write here a bar, and whatever is the divisor, if it's in the form of x minus c or y minus c, get the opposite of its sign. If this is minus c, we write that minus c as positive c here. In this case, if it's positive c, if we get its opposite, it will become negative c, and we write that negative c around here. On this case, however, we see y minus 3. The opposite of negative 3 is positive 3, so we write that positive 3 here. The third step is that we draw this bar under 2, 3, and negative 11 and drop down the first one, which is 2. Next after that is that we follow this step. We multiply the thing that we brought down, which is, which is 2, right? We see that we brought down 2. So what we do next, we multiply that 2 to what we write here earlier, which is 3. So this will become multiply, and whatever is the answer, once we multiply, we will put that below to the next one. It should look something like this. So multiply then equal. So 2 times 3 is 6. So we put that 6 here. And then we proceed to add the next one. What is 3 plus 6? It's gonna be 9. And we do the same steps. So we multiply this 9 to 3, which is 27. And we write that 27 below negative 11, which we will have positive 27. And then we add, the answer will be 16. And once we reach this end, we are already done. Remember, earlier we write this as y squared, y, and the constant. Once we write this y squared, whatever is below this now corresponds to the next one. What do I mean by the next one? We now correspond to y, the constant, and the last but certainly not the least, this is the remainder. If we write that back, since this is corresponding to y variable, this will become 2y, and the constant being 9, or positive 9 plus 9, plus the remainder of 16 over the divisor, which is y minus 3. We confirm 2y plus 9 plus 16 over y minus 3. Okay, here. So we arrive at the same answer. Just to confirm if this is true, I will just do this quickly. So writing m squared minus 2m minus 24 divided by m plus 4. We write their numerical coefficients in order. M squared is 1, m is negative 2, the constant is negative 24. The opposite of positive 4 is negative 4. First step, dot bar, drop the first one, we will have 1. 1 times negative 4 is negative 4, and we write that here. Negative 4 plus negative 2 is negative 6. Repeat the step. Negative 6 times negative 4 is positive 24, and positive plus negative of 24 is 0. We started up with m squared, then m, and constant. We start at the bottom now with m and the constant and the remainder. If you look at this, 1m or just m and the constant being negative 6 is indeed the quotient, thus verifying our answer. Next, let's verify this. We have y cubed. The numerical coefficient of y cubed is 1. The numerical coefficient of y squared is 3. The numerical coefficient of y is negative 2. The numerical coefficient of the constant is negative 5. And the inverse of 2 is negative 2. If we do so, we will arrive at this. We bring down first 1. Then 1 times negative 2 is going to be negative 2. We add these two. 3 plus negative 2 is 1. We repeat. 1 times negative 2 is going to be negative 2. If we add these two, it's going to be negative 4. And negative 4 times negative 2 is positive 8. 8 plus negative 5 is going to be positive 3. We started off with y cubed. This is going to be y squared. And so on. Y, the constant, and the remainder. If you write that back, it will look something like y squared plus y minus 4 plus 3 over y plus 2. Thus confirming the answer. Here is the practice that you can do for the rest of the time. You can pause this part to check if you indeed answered correctly. Now, I will include something that is not in the output. Why is the reason why we get the opposite of something? Let me explain that elaborately. Let me grab an example first before I explain it. So, okay, let's use this example. So, first things first, we have a separate example here. Let me write it below this one. So now here, we start here. So, let's say I have x squared plus 5x plus 3 divided by x plus 6. So again, the divisor should be in the form x minus c or y minus c or even x plus c and y plus c. Anything goes as long as this is a singular number without any numerical coefficient greater than 1 beside it. So, with that being said, we start off by writing their numerical coefficients on the dividend, which is 1, 5, and 3. The divisor, the reason why we get its opposite is because it looks something like x plus 6 will be equal to 0, and we need to solve what x is. And lo and behold, in an equation, for just the simplest thing, we use this method na lagi nyo maririnig from teachers moving forward. We transpose. Meaning, if we move a number or a variable to one side of the equation to the other side, it will become its opposite sign. On this case, if this is positive 6 and we put it to the other side, it will become negative. So, negative 6. That explains why we use its negative opposite. Alright, the opposite of C, or in this case, positive 6. So again, we do the method. 1 here, multiply 1, negative 6. Add here, gonna be negative 1 times negative 6 is gonna be positive 6. The remainder is 9. So if we check that, that is x minus 1 plus 9 over x plus 6. But here's the thing. What if we have a given wherein it looks something like this? 2x squared minus 17x minus 38 divided by 2x plus 3. Okay, for the first step, it's still normal. It's 2, negative 17, and negative 38. But for the second step, however, you should not put it as just negative 3. That is indeed wrong. What we do here, again like earlier, is that we write 2x plus 3 is equal to 0. We need to keep this separate. How do we keep that separate? Let's move the other one. So that positive 3, if we move that to the other side of the equation, it will become negative 3. And we are left with 2x. Again, I just want this to look like x is equal to something. What's good about this, I can remove the number beside 2 by dividing both sides of the equation by 2. Doing so, we have x is equal to negative 3 over 2. And that is the thing that we need to write here. Doing so, first, let's drop off 2. 2 times negative 3 over 2 is negative 3. And if we add that, that will become negative 20. Negative 20 divided by, times negative 3 over 2 is gonna be positive 30 in this case. And if we add that, negative 8. Thus we convert this, since this is x squared, this is gonna be x constant remainder. 2x minus 20 plus negative 8 all over 2x plus 3. So I will leave that with an end note. You can solve this for your own. And with that, thank you for listening to this session. I hope that you learned something. If you have any questions, just let me know and I'll answer it as much as possible or as soon as possible. And with that, OtsuHaku. Bye bye.